We can take a look here in our columns menu on the left side to note that we have several character columns of data, as well as now our 3 new continuous measures indicated by the blue triangle. In addition, we have several plus signs here that indicates a formula. If you'd like to quickly view the formula, simply hit the plus sign and it will open the window. Let's begin working with the percent resistant numeric. So analyze our distribution and put that in the Y and press OK. What you can see here is the default histogram that JMP has decided is appropriate for this data. Now remember, JMP doesn't know. Remember, JMP doesn't know what the data is. It simply takes a look at the distribution and picks something appropriate for the axis. So we have our histogram and we have our box plot. Your options underneath the red drop-down area, you can add, if you want to add the counts, you can show counts. That will get you the counts that are in each of these bars. If you would like to change the axes, you can right-click for axis settings, and it will bring up another window. You could change the minimum and the maximum, or you could change the increments. So let's say we wanted to look at it by 20 and press OK. And now you can see that the number of observations in this bar has greatly increased from the prior 42. So now we have 42 and 28 that are encompassed within this. You could then go to revert to axis settings. We'll take it back to the original. You can also, if you need to, change, if you wanted to look at a minimum of 0 and a maximum of 100%, press OK. And you can see here that actually changes the way that the data looks. From before, it looked a little bit more symmetric, and now it looks slightly more skewed. You could also remove the box plot. And if we take a minute to look at the box plot here, you can see we have one data point that is considered an outlier. We have the whiskers of the box plot. We have the mean, which is represented by the triangle, and the median, which is represented by the line. And then we have the ranges that are associated with the specific boxes. You can also change the histogram to be, if you remove the vertical, it will then show as horizontal. And anytime you click on a bar, you can see that there are now 42 rows. You can see that right here, 42 rows selected. If I click on the 28, there are 28 rows selected. So this is a very good way to quickly identify rows in your data. If I click on this one outlier here, you can see that there is 1 row selected. And if I go back to my data, to the rows menu, and ask for next selected, it will actually take me to the row that had the lowest value, or that 16.7% of samples were MRSA positive. So if we go back to our window of our distribution, I'm going to actually remove my histogram, and I'm going to remove my outlier box plot, and we can take a look at the quantiles and the summary statistics. The quantiles, or percentiles of data, show you what percentage of the data is below that percentage. The median, as we know, is the 50 percentile. So that means 50% of the data is below 47.4 and 50% of the data is above 47.4. Our minimum, or our 0th percentile, is 16.7. That's our lowest data point. There is no data lower than that. And our 100th percentile is 73.8. That is our maximum value, and all of our data is in fact below that number. The most common percentiles will be the 0th or the maximum, but those are called the minimum and the maximum. The median, and then the interquartile range, which is this, the 25th percentile and the 75th percentile. So often you'll hear people talk about quantiles, that we wanted to do things in quantiles or quartiles. The quartiles would be the 25th, so this 25% of data, the next 25% of data, the third highest 25% of data, and then the fourth highest 25th% of data. That's the quantiles. Then you can look at the summary statistics option, and it shows the moments of the distribution. The first moment is the mean. The second moment is the variance, and here it's shown as the square root of the variance or the standard deviation. We then have the standard error. The standard error is actually a measure of the variability about the mean. It is directly associated to the standard deviation in proportion to the square root of the sample size. The standard error will always be smaller than the standard deviation. You only report the standard error when you are talking how much confidence you have about your mean. When you are trying to describe your distribution, you report the standard deviation. Now, the assumption is that if you report a mean and standard deviation, then you have a roughly symmetric distribution, somewhat like we have here. It's roughly symmetric. We can see that our median and our mean are very similar. We can see that the distance between the median and 75th quartile and the distance between the median and the 25th quartile is roughly equal. And then we're not too far off the distance between here and the distance between the top, the maximum, and the median being similar. So we do have a roughly symmetric distribution here, and so reporting a mean and standard deviation would actually be appropriate. However, if we go into our Analyze menu and do a distribution on the number tested, we can see that the number tested is actually quite skewed. So we do not actually have a very symmetric distribution. If I make this a horizontal box plot, you can see even better that this is not a symmetric distribution. You can see there are quite a few number of outliers, very long tail. You can see that the median and the mean are not similar. You can also see that the distance between the median and the minimum, which is about 130 points, is much smaller distance than the median to the maximum. If you have roughly normally distributed data or roughly symmetric data, the distances between the median and each quartile, plus or minus, should be roughly the same. If you have roughly symmetric data, your median and your mean should be similar. And of course, as we've seen with large standard deviations, that means you have a lot of spread about your central measure of central tendency. And in this case, it's a mean. So these are the defining characteristics of your continuous distributions. Remember, JMP does not know what you are displaying and therefore is by default going to give you somewhere between 4 and 6 decimal places on your summary statistics. Don't simply report that because JMP gives it to you. We know that these are round numbers or integers, and so 1 decimal place is sufficient. We know that these are percentages, so 1 or 2 decimal places is sufficient. You will need to edit your data down from what JMP gives you. What is useful is that if you right-click anywhere in these tables, you can actually ask JMP to make you a data table. And now I have the values of my quantiles, or I could right-click in over here in my summary statistics, make into data table, and you can see now that I have my moments. And so if I do need to cut and paste, I certainly can, but you do need to edit down your decimal places to what is appropriate for your data. There are a number of different ways to get summary information out of JMP other than just using the Analyze menu. You can use the tables and summary. And you could ask JUMP for the num-tested mean, the num-tested standard deviation. I could ask for the median, and I could ask for the interquartile range. And JUMP will give you a new data set that has the columns associated with what you're looking for. If I go back to my main data set and ask for a distribution of num-tested, you will see that the results are actually identical. So you can see my median down here is 152 and my median here is 152, and then my mean and standard deviation are the same. So it is the same information. Something else that you could do is utilize the tabulate option, and JUMP will bring up basically a blank table. And so again, I could ask num tested, and I could drop that into my resulting cells. That's giving me a total sum, but I could add to it the mean. I could add to it the standard deviation. If I wanted both, I could then put in a row heading. If I also wanted means, I could put it at the bottom. If I wanted the median, I could add that again, another row. So there are many ways to get data from JUMP using either the Analyze menu, the Tables menu, or the Tabulate menu. How you choose to write up your summary information for these three variables will depend upon the shape of the distribution and what it is you're trying to say about the distribution. So you'll need to choose an appropriate measure of central tendency, either the mean or the median, an appropriate measure of the distribution or dispersion of your data, either the interquartile range, the minimum and the maximum, or the standard deviation. Remember, the standard deviation describes your sample. The standard error describes the confidence you have about your mean estimate. So when you are describing your sample, report the standard deviation. In addition to that, remember a mean and standard deviation imply you have symmetric data, whereas a median and a range are better for skewed or non-symmetric data.